Hello friends, now we are going to discuss the periodic trends in periodic table. There are the different properties. There are 10 important properties of periodic table which play a very important role to deciding the different features of the every element. These properties are ionization potential, non-metallic character, oxidizing power, hydration energy, electronegativity, electron affinity, reducing power, atomic radius, metallic character, acidity and basicity, and much more. This is a periodic table. In this periodic table, it is a very systematically arranged, and on the eve of this international year of periodic table, I want to mention number of things related with the periodic table. Initially, the periodic table has been investigated by Mendeleev in 1859. This is the 150th year of periodic table, and on this occasion, this year 2019-20 is celebrated as International Year of Periodic Table. These periodic table now contain 180 elements. Among them, 2 are liquid, and other 11 are gases, and other are solids. The liquid are, one is a metal, this is mercury, and one is a non-metal, it is a bromine. And in the we are going to discuss the periodic trends of the all periodic table. The vertical lines are called as columns, the horizontal lines are called as periods, and all these you are everybody must know about the related with the basics. Now we are going to discuss one by one property in a simple and liquid way. First is the ionization potential. As the trend shows that from left to right, from starting from lithium to neon, the ionization potential is increased and suddenly it is decreased in the case of oxygen. Whenever I discuss the periodic trend, as well as same time I will discuss the drawbacks of these periodic trends. See, this is the abnormally oxygen has less first ionization potential. That is because of the electronegativity factor. That may be the electronegativity factor. But if the electronegativity factor is there, then what is about what is in the case of fluorine? Because fluorine is the most electronegative element in the periodic table, and oxygen is the second most electronegative element in the periodic table. That creates ambiguity. So, in a simple way, we can remember the oxygen has abnormally has less ionization potential as compared to other, but the sequence is the followed. That is, from lithium to neon, the ionization potential increases slightly. And that clearly indicate, we can make a thumb rule that from left to right of the periodic table, the ionization potential increases steadily. Instead of only exception is the oxygen. Right? Okay, from the top to bottom we are discussing now. From lithium to cesium, in the first column, we can see the ionization potential is decreases sequentially, and that clearly mentioned that from to left to right the ionization potential increases, from top to bottom it is decreases. It is followed for every other columns. That is we can, on the basis of that, for our convenience, we can make a simple thumb rule, that is first ionization related with the first ionization potential. These thumb rules are so much important in the case of different computer exams like CSIR-NET, GATE, SET, PET, DRDO, and any other else. Whatever the computer exams there, in that examination, such a thumb rule are so much important for us. Then again, next property is the Pauling electronegativity. There is the Pauling scale is there to determine the Pauling electronegativity, and we can see in the periods and in the column. In a periods, see from the lithium to fluorine, we are not considering the noble gases for electronegativity because all the orbitals are filled with electrons, right? So in the case of lithium it is 0.98, while in the case of fluorine it is a 3.98. See the increasing order, it is increased from 98, 158, then it increased steadily. That clearly make a thumb rule that from left to right of the periodic table, the electronegativity is increased steadily. While in the column or lithium 0.98, 93, and abnormally again sodium has more and these. Again, 82, rubidium 82, and cesium 79. That means from left to right it is increased steadily, but from top to bottom it is not increased steadily. Abnormality sodium has shown all they are slightly less their speed. The rate, the difference between them is lesser as compared to the lithium to fluorine. So that we have to remember for a simple way. That means in a simply we can say from left to right electronegativity increases, from top to bottom it is decreases. This is the example of, this is the halide of nitrogen family, NF5, NCl5, NBr5, halides with fluorine, chlorine and bromine. And then we have to play this may be there. Now next is the periodic property, diagonal relationship. This is one of the important property. The questions are frequently asked on it for set examination, and lithium is diagonal with what? They are given the number of options. Among them it is magnesium. And lithium is diagonal with magnesium. That clearly indicate diagonal relationship. That means these show by lithium and magnesium. That is means what? Lithium has some important property that are matched with the magnesium. That means lithium as well as magnesium show some common properties, although they are put in a different columns. Okay, that's the diagonal relationship. Next, enthalpy of atomization. The enthalpy of atomization of D block elements are higher than that of S and P block elements. Okay, and enthalpy of atomization increases with increased number of valence electrons. That means number of valence electron increases from left to right. Enthalpy of atomization is obviously increased from the left to right and decreased from the top to bottom. That is a simple thumb rule for in the case of enthalpy of atomization. The next is the melting points. Melting points of element shows much more randomness in its strain. That's why we cannot able to explain or we cannot able to make any thumb rule in the case of melting points. Okay. Allotropes. There are the different allotropes are there. As far as the allotropes concerned, carbon has shown the 4 important allotropes: diamond, graphite, and amorphous, fullerene, and carbon 60, C60. Then S17 has a gray and white, phosphorus has a white, red, and black, arsenic has yellow and metallic gray and black, and SB has blue, yellow, black, and bismuth has amorphous crystalline. Oxygen and dioxygen and ozone, that is important in a stratosphere of the earth crust, right? There are the different layers of in the environment. In the stratosphere, ozone play an important role. They absorb the ultraviolet rays which are directly come from the sun. Then sulfur make catenated rings, chain and amorphous. Then selenium has red, alpha, beta and gamma and type of allotropes. Then the important property is the oxidation states. The inert pair effect lead to an increasing stability of oxidation state, that is 2 less than the group oxidation for the heavier elements. D block elements exist variable oxidation states from +2 or +3. Then this is I have shown you on your desktop that scandium to zinc, that is the first row transition elements. They have the variable oxidation state or depend on the number of electrons present in their outermost orbital. And among them, manganese has shown maximum variable oxidation state, starting from +2 to +7, right? That means as go from left and as go towards the right, the oxidation state, the variability goes on decreasing. They are come towards the less and less oxidation states. Transition elements, simply we can say transition element shows the variable oxidation states. Then oxides of elements. There are the 3 parts of the important bonding is there. I already stated in hydrogen presentation that there are the saline, intermediate, metallic and molecular type of bonding. And these first group, that is alkali group element, shows the saline properties, while magnesium and barium are intermediate among them. Again, the calcium, strontium, beryllium shows the saline property, and among them some transition elements are show the metallic property, and generally the p block elements are shows the molecular properties. These are already explained in our previous video, that is from the hydrogen. Metals form basic oxides non-metals form acidic oxide because of their property. The elements form normal oxide, peroxide, superoxide, suboxide, non-stoichiometric oxides. Then binary oxygen compounds. This is a huge task to understand these binary oxygen compounds, and it play a very important role to create a different types of questions for our computer exams, and that's why therefore this topic is so much important for us. The high reactivity of oxygen and its high electronegativity lead to a large number of binary oxygen compounds, many of which bring out high oxidation states in a secondary elements. Then acidity nature of oxides. The acidic nature of oxides increasing across the row and decreasing show down a group for a given oxidation state. In a group 13 elements, at the head of the B boron is the non-metal and form the acidic oxide as a B2O3. At the bottom of the group, the metallic character has increased and the inert pair has played important role to reduce the stable oxidation state from +3 to +1, and the oxides of thallium is basic form Tl2O. Next is the halides of elements. The S block halides are predominantly ionic in nature, while P block elements are predominantly covalent in nature, and in D block elements, low oxidation state halides tend to be ionic and high oxidation state halides tend to be covalent. These are the different halides of all periodic table, with some exceptions with lithium and barium. The S block halides are ionic and P block fluorides are predominantly covalent. Fluorine and chlorine bring out the group oxidation number in most of the elements, as well as an oxidation number too lower as expected from the inert pair effect. Exception: nitrogen, sulfur and oxygen form only lower oxidation state halide. That is so much important characteristic that we have to remember for to attempt the different questions in the competitive exams. Now, in the last version of our sake of video, we are going to understand 1 to 2 questions. The electronegativity of following element: hydrogen, oxygen, fluorine, sulfur and chlorine are increases in the order of, I have given order, and simply we can say there is the hydrogen is the primitive element, first element of the periodic table, and you know that we have make a very simple thumb rule from left to right. From left to right, the electronegativity increases and top to bottom it is get decrease. The same phenomena, we can arrange the elements, we can put see the periodic table and see the elements, they are placed in a simple way. In the left to right increases, top to bottom decreases. We can come on the conclusion. The answer is D. And in next now, arrange the following in increasing order of their atomic radii: sodium, potassium, manganese and rubidium. In this again the simple way, we have to see that increasing order of atomic radii. I already state you that atomic radii from top to bottom it get increases, and again magnesium, potassium and left to right increases, top to bottom. That simply way there is simple answer is a B. And in this way I try to give you the different examples of all these related with the alkali. I'm able to explain the periodic trend of periodic table in a simple and liquid way. Thank you. Thanks a lot.